Hi all. The last video we have seen about the data mining and the methods that are used in data mining. So in this video we are going to see about data integration. What is data integration? From the word itself we can understand integration, something integrating, data integration, integrating data. So integrating data from different sources. So combining data from multiple sources into a coherent store. Schema integration. In few databases you could say you could store the customer ID as cust ID, and in some of the databases the customer ID could be stored as cust hash. In some of the databases they could have stored customer ID. So the same attribute could be stored in different names. That is what is data integration from multiple sources. So multiple sources will have different names for the same attribute. So integrate metadata from different sources. So entity identification problem. So because of this integration from the same attribute from different sources, identifying the real world entity from multiple data sources will be a real challenging. For the same real world problem, for the same real world problem, attribute value from different sources are different. For example, some database will have customer first name, or some of the database will have customer name. That's it. So the first name, last name, everything will be combined. Whereas some will have customer first name, customer last name, customer middle name. Just for one name, just for the attribute name, one database might have just a name on the whole name. One might have the first name, last name, someone will have customer first name, middle name, last name. So when you want to combine the different sources, databases, sources from different sources, that will become a real challenging because of different representations, different scales, if it is going to be the numerical, and if it is going to have different metrics or different units. So handling redundancy in data integrations. So if it is going to be from different, we will not know. So customer ID, customer hash. So in the example we saw customer ID, customer hash. If the technical person is not involved in data integration, he is just going to pull out the data from different databases and then he is going to merge it. He will not know that customer ID and customer hash are same. So in that case, what he will do, he will merge all the data from different databases. In that case, the redundancy will happen. Redundancy is nothing but duplicates. The duplicates might happen. So the redundant data occur when integration of multiple databases happens. There is integration of multiple databases happens. So object identification and derivable data are one of the two important challenges that we have. The same attributes or objects may have different names in different databases. So object identification is a major problem. So as I told you, customer ID, customer hash, where both are same attributes, both are going to have the customer ID, but he doesn't know customer hash, which is nothing but represents some number ID. So identifying that object will be really difficult. So if we are not going to identify that, we will feel that that's a different customer hash is a different attribute, and then we'll just derive and put it in our, or we'll just derive and we'll integrate in our database where the redundancy would happen. And then the derivable data. So one attribute may be derived attribute in another table. So annual revenue. So in one database, annual revenue would be a separate attribute, where in another thing they will have it as a combined attribute. So derivable data also could cause redundancy in data integration. So redundant data, that is redundant data or attributes, may be able to be detected by correlation analysis. So handling redundancy is very important in data integration, because avoiding data redundancy during data integration is almost very difficult, because somehow you have to handle redundancy in data integration, because data duplications in data will happen in data integration. So in that case, what can be done? So by finding the correlation analysis between the data would help to deal with the redundant data. Careful integration of the data from multiple sources may help reduce or avoid redundancies and inconsistencies and improve mining speed and quality. Though the careful integration happens, redundant attributes will occur. In that case, correlation analysis will help in handling the redundant data. Data integration. So for numerical attributes, we can evaluate the correlation between the two attributes A and B by computing the correlation analysis. So correlation analysis we spoke about, right? So this correlation analysis, we have various correlation analysis, Pearson correlation, correlation coefficient, there are a lot of things, whereas you need to carefully analyze because the formula that you can use it, the correlation analysis method that you are using for numerical cannot be used for categorical attribute. Numerical is nothing but whatever you are having it in numbers 1, 2, 3, or in float numbers 22.3, 22.5, whatever you're having in numbers are called numerical attributes, and your names and your department names, whatever it's in ABCD, right? So that those things are called as the categorical attributes. So those are called categorical attributes. So the formula or the method that you can use it for your numerical attributes cannot be used for your categorical attributes. So it differs. So you should know which correlation coefficient can be used for the categorical and which should be used for the numerical attributes, right? So here you have a correlation coefficient formula where correlation coefficient A comma B, where A comma B are nothing but the two attributes. The formula for that is sigma of I is equal to 1 to n, the number of elements. So AI, each elements, minus A mean, that is, this is A mean, the overall mean of the attributes of A, and then BI, each element of the set B, minus B, the complete overall set of B mean, divided by the overall components into standard deviation of A into standard deviation of B. So this formula can be written like this. So in case the whatever the output that you are getting for this correlation coefficient, if it is greater than 0, then it means that both the attributes A and B are positively correlated. It means that if the A value increases, then B also increases. And it also tells you that both A and B are highly correlated. And if the value is 0, then it means that A and B are no way related to it. And then if the correlation value is less than 0, if it is negative value you are getting it, it means that A and B are negatively correlated. If A value increases, then B value decreases. So based on this correlation, we will be seeing the chi-square test in our next video. Thank you.